So today is our second lesson on our new topic. If you haven't watched the first lesson, please make sure you do first. If you have already, you know that the topic is Pythagoras Theorem. And when we say theorem in maths, we tend to use this shorthand. And that is used when we have a right-angled triangle. And we have a special name for the longest side opposite the right angle. See if you can remember it now. It is hypotenuse. And we often abbreviate it with just HYP. It's important that we always label our hypotenuse first, so that way we make sure we use our formula correct. Traditionally, it's written as a squared plus b squared equals c squared. And that's really us just saying it is the sum of the square, so sum means adding, of squaring the two perpendicular sides of a right-angled triangle, and they will give you the square of the hypotenuse. So it's important that your hypotenuse is always labeled as your c in that formula when it's that way. What we're going to do now is I'm going to give you some problems as your starter, where you're going to need to use this formula to determine if the triangles I show you are in fact right-angled triangles. So do make sure that you pause the video and try these problems. So we're going to start with the first two. I'm going to show you how I've done them. And then again, I would suggest that you pause the video to correct anything that you potentially need to on C and D. So for these first two, what we're saying is this angle right? Is this angle the right angle? And the reason why I would know it would be those is because if this is a right angle triangle, the right angle is always opposite our hypotenuse, and our hypotenuse would be the longest side of a right angle triangle. So if they are, those would be our hypotenuse. So I'm going to go ahead and substitute into my formula and say the perpendicular sides, if I add them together after I square them, does it give me the side opposite, or the longest side, to be a perfect square? So 6 squared is 36. 8 squared is 64. 36 plus 64 does in fact give us 100. Which why I say does in fact give us 100 is because 10 squared is 100. So since Pythagoras' theorem held true, yes, this is a right angle triangle. Now we're going to do the same thing for the next one. So go ahead and see if you got that next one correct. So you should have had 25 plus 49. And you're trying to see if does that add up to 81. If you do 25 plus 49, you get 74. So that does not equal 81. So this is not right angled. So if you think that you've done the others correct, go ahead and just skim forward a little bit, because I'm going to put you back to the original problems for if you need to make any corrections. Otherwise, take a moment now and determine if C and D you did correctly the first time. So as you can see, C was in fact a right angle triangle, and D was not. So looking at these, D is definitely one I would expect you to use your calculator on. Now what we're going to be working on today is where Pythagoras sometimes gets used. And that is for finding the distance between 2 points. So that was a little bit of our revision and use of Pythagoras in a different way. And now we're going to look at the distance between 2 points. So when we're given the distance asked to find the distance between 2 points, we're often given the coordinates. For example, knowing that this point is at 3, 7. And this one is at 10, 10. And what we want to find is this distance. So maybe you see it right now, but this links to Pythagoras' theorem. And remember, Pythagoras can only be used if you have a right-angled triangle. So we need to be able to create that perpendicular somehow with these 2 points. And we do that by drawing the horizontal and the vertical. And the horizontal in this case is our x direction. So we need to say, how do I get from 3 to 10? Well, we do 10 minus 3, which gives us a horizontal movement of 7. Then we also need to say, how do I get from 7 to 10 for my vertical movement in the y direction? So 10 minus 7 gives us a horizontal movement of 3. Now that we have our horizontal and vertical components, we can go ahead and apply Pythagoras' theorem and say 7 squared plus 3 squared will give us the distance of our line squared. Because the distance in this case is the hypotenuse of the right angle triangle. And I know it's right angle because the horizontal and vertical are perpendicular together, which means they meet at 90 degrees. So 7 squared is 49. 3 squared is 9, which gives us 58 as our d squared. So using my calculator, I can see that by square rooting 58, and I can press the S to D button, which changes it into a decimal, it is 7.61577. Now, I'm going to give this answer to 3 significant figures. 3 significant figures means you count from the first non-zero digit, and all digits count. So 7, 6, and 1 are my first 3 significant figures. And because we're rounding, you always look to the number after. And as it's 5 or bigger, I'm going to change this figure. So it becomes 7.62. And that's the distance of our line. I'm going to give you another one to try, and then you have homework on my maths to go ahead and do, which will have you do your Pythagoras as well as applying Pythagoras to a distance. So I want you to go ahead and find the distance here. So pause the video and see if you can do that. You should have given yourself your horizontal and vertical lines, which will create your perpendicular of your right angle triangle. As before, the horizontal is the difference in your y values. So x values for horizontal. So this time I have 4 minus a negative 2. And minus a negative becomes a plus, meaning there's 6 units of travel horizontally. And then the vertical distance in this case goes from 3 to negative 6. Again, the double negative becomes a plus, so there are 9 units of travel. And if you have either of these as a negative value, that'll be okay, because when you go to Pythagoras' theorem, squaring a negative 9 would be the same thing as squaring a positive 9. So when we use Pythagoras, the horizontal distance is 6, plus the vertical distance gives us our overall distance squared when we add them together. So that's 36 plus 81 will give us our distance squared. And if I add 36 to 81, I get 117. So as before, I'm going to square root that 117, which gives me 3 root 13, or to 3 significant figures. You just can't start with 0, but 1, 2, 3, 10.8, and the 1 after says rounding keeps the 8 in 8. So 10.8 is my distance. All right, go ahead and try your work on My Maths, and do make sure that you put on Show My Homework any questions you might have.